Okay, this is the first video of 2 for section 8.1, combining functions. There's two different sections that include in which we learn how to combine functions. This is the first one. In this section, we're going to do addition, subtraction, multiplication, and division of functions. That means you have two different functions and you add them, you subtract them, multiply them, and divide them. And then the second one will be in the next section, 8.2, and that's a composition of functions. So you'll have two functions and you'll compose them. And the composition is shown by this open dot. That's just the symbol for it. And you'll see what that means when we get to it. Okay, so these are used to construct more complicated functions out of simpler functions. So, first, the function f plus g, that's the name of the function is f plus g, right, is a function constructed from functions f and g by, and how do you define the function? You tell it what does it do to an input, right? That's how you define a function. So f plus g of x, notice the parentheses is around f plus g. That's so you know the name of the function is f plus g. And you don't think that you're adding an f to a g of x, which wouldn't actually make sense unless f was a constant. So f plus g of x, that's how that's said, equals, the colon in front of the equals just means equals by definition. It's not something you need to know, it's just something I have a habit of doing. So it equals by definition f of x plus g of x. So what does it mean? If you have the input x, then the output of f plus g will just be the output of f at x and the output of g at x. So it's really the most obvious thing you would do. The thing that you would do if you were guessing is probably exactly this. Now, if you were to guess what f minus g, what the definition of that was, you'd probably guess you take the outputs and you subtract them. Now, this can also be looked at another way. If you have a formula for f of x and a formula for g of x, then that right side of the equation, f of x equals blah, 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 and the right side of g of x equals blah, 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 you're just taking blah, blah, blah 1 minus blah, blah, blah 2, right? So like f of x equals x squared, g of x equals x cubed, f minus g of x is x squared minus x cubed. Almost forgot what my example was. Okay, f times g, also written with the parentheses around the f times g, of x equals, by definition, f of x times g of x. See the pattern? Pretty simple, right? And then f divided by g is defined by f of x over g of x. But here we have to be careful that g of x is not 0. So you can't use any x's where g of x is 0. And this has to do with the domain. So this is how these things are defined. Then the other thing we need to know is how do we know what the domain of these functions are? You know, so where does this come up? So suppose you have a polynomial, just a simple one, like f of x equals x squared plus x. Well, that's a sum of the x squared function and the x function. The x squared function would be like f of x equals x squared. The x function would be g of x equals x. And you've taken f plus g of x, which is x squared plus x. So you build up polynomials this way. If we didn't do this, we wouldn't have polynomials with more than one term. And of course, the minus one, number 2, is needed because sometimes you want to subtract those terms, right? Times, well, suppose you had the square root, say you had x squared times the square root of x. Well, f of x equals x squared. G of x equals square root of x. And I've taken f times g of x, which is f of x times g of x squared times the square root of x, you see? And division, rational expressions use this division, which we just did with inequalities, right? F over g of x. Suppose f of x is x minus 1 and g of x is x plus 2. Then f over g of x will be x plus 1. Wait, did I say plus? Let's just pretend I said x plus 1 over x plus 2. Forget my example. Okay, so of course on the next page I'll have some examples and we'll talk about domains. This is just a definition of how you find the domain. The domain of each of these, any one of these, the first three are going to have the exact same domain. The fourth one might be a little different because you're dividing by g, right? So domain of each is domain of f intersected with the domain of g. Why? Because in order to plug a number into the function f, it has to be in the domain of f. In order to plug a number into the function g, it has to be in the domain of g. So in order to plug something into something that's defined by f of x plus f of g, for example, you have to be able to plug the number into f and into g, because otherwise you'd have, say, f of 1 plus something that's not defined, which would mean that f plus g would not be defined for 1, the number input 1. So that's why it's the intersection. The intersection means that it's in both of the domains. Okay? Now f over g, you still would take the intersection of the two domains, but you would also have to exclude any values of x for which g of x is 0. So say g of x was x minus 1. You'd have to exclude the point x equals 1, even if it was in the domain of f and the domain of g. In other words, it's not in the domain of 1 over g, okay? Because you can't divide by 0. So that's the first little clip on that. The second one has examples written out.